morning. I'd like to thank you for joining the Jenny and IBM Interconnect Comes to You webcast, where you'll learn about best practices around IBM Tivoli Network Manager and how you can leverage Jenny to do some of the heavy lifting for you. I'm joined by Jenny Director of Professional Services, Sean Ryan, and Rob Clark, who covers development for network management within the IBM Software, Cloud, and Smarter Infrastructure product suite. Rob Clark is going to begin the discussion around deployment with IBM NOI, and will then cover best practices pertaining to discovery, monitoring, events, and administration tasks. Sean Ryan will then wrap up with a few ways that clients can leverage Jenny to ensure that they're making the most of their Netcool investment. Before we begin, I just want to ask that you submit your questions via the chat window, and that questions will be fielded in the order that they are received. If for any reason you're experiencing difficulty viewing the web presentation, please send me an email at kate, K-A-T-E, @gen-e.com so that I can send you a copy of the presentation. Also, a recorded webcast will be available within 48 hours. I'm now going to hand the floor over to Rob.
Okay, thank you, Kate. Hello, everybody, and thank you for Jenny for inviting me today. I'm going to cover some of the best practices for Network Manager, ITNM product, that I hope you'll find useful. I want to start off with a quick look at Network Operations Insight, NOI. This is a repackaging of our network operations products, and you may be hearing a lot about that at the moment, and want to see how your existing network manager could fit into this. It actually fits into this without any migration. If we look at the slide here, on the left-hand side, on the right-hand side, we've got the actual NOI, what we call the Network Operations Insight, which includes the dash, the latest omnibus, impact, and analytics. Now, to hook Network Manager, and basically you hook up to the new omnibus, so it's just a reconfiguration to hook up to the omnibus. You use the tip to redirect all the pages through dash so that operators as well as the administrators would log into dash to see all the pages from tip. You wouldn't know that tip was there. So there's various scripts that help you reconfigure this. Those are outlined in the from the link at the bottom of the screen. And while I'm on this slide, I just want to give you a quick idea of what we're working on in this next release, which is targeted for the end of the year. Obviously, tip is not an ideal situation in this environment, so that's gone. Network Manager will be deployed completely or natively within dash, and the other the Java applets that we all know and love will also be gone, and it'll be all native topologies, making it a lot faster and without the security hassles. In addition, we have a new network health dashboard, and I don't have a picture here, but basically this dashboard allows operators to view their area of responsibility. That's basically a network view. So it could be their area of responsibility being technology-based or regionally based or services-based, however you set up your network views, for instance. And that will control the context for the other widgets on the page showing information from all the data sources, for instance, the events, the data, the performance, the polling, historical data, if you like, the performance data, KPIs from like bandwidth utilization and so on, historically, showing top-end views for that region. If you have Network Configuration Manager, it also hooks up to show you configuration changes so that you can visually correlate configuration changes with on the timeline with events. So that's one of the big pieces for the next release. So if we go on to the next slide. So back to the best practices. If you have, well, with the VMs frequently used to host our products now, we get asked a lot about moving the VMs or copying servers to clone the deployments. This, of course, involves a lot of re-IP work within the products. And while we're looking to make this easier, it still involves a little bit of work. So in the meantime, we've got links down at the bottom here that show you what needs to be changed on each of the products. So next slide, please. So the next section, we're going to look at discovery. Next slide, please. So some of the provisioning aspects within the discovery to make life a little bit easier as you in your day-to-day work. First, let me take you through the discovery so that you can see the discovery flow and where the different pieces fit in. So this is useful to keep in mind when you're configuring the discovery to see where in the flow the different pieces fit. So it starts off down at the IP assets at the bottom there. They're your network devices, obviously. You configure or specify the scope, the IP addresses, and we go out and we ping. So we ping everything that's in the seeds, and we ping, if you've configured subnets, for instance, we'll ping spray those as well. So anything that comes back successfully, we then make a note of that, send them out SNMP, looking for the sysobject ID, and fill all those that information into the details. So now we've established a network device. We know it is up on the network at the moment. It either responding to SNMP or it doesn't. So we record that together with the sysobject ID if it did. At this point, there is a pre-discovery filter that you'll see on the discovery configuration. And you can use that filter to use any of the information in the details table there, typically the sysobject ID, to filter out devices that maybe are not interesting. These might be printers or other end nodes, for instance. So that's where that fits in. At that point, all the agents, each agent has its own filter on what it is responsible for. So it takes the information from the details table there after the filter and goes out and does the SNMP queries that it needs to do to find its information. So each of those go off. At the same time, this is where the collectors, if you're using any EMS collectors, or even the CSV collector, which can often be handy to pull in devices that you can't get to. So all this information then is pulled into the agent tables represented by those blocks. And that continues until it's finished, or until 90 seconds, the blackout period has passed for the pings. So if pings have, nothing has come back from the pings for 90 seconds, it then assumes that we're done with the collection. Because this might not be true, there might be something coming back later, in which case we hang on to that response. And at the end of the whole discovery, we go back and redo the discovery using those devices that might have come back late. Anyway, at that point, we then hand it over to the stitches, to the stitches, which will basically do two things. One, they'll analyze all that data and build the containment links. In other words, the devices to the interfaces, to the slots, to the and all the logical links within the device itself. It also looks at all the connectivity. So it'll look at all different layers from build the connections from layer 2, layer 3, and so on, OSPF, all the other logical links and physical links, and put those together. So that results in the discovered topology. So it's same data, but now we've got all the links there as well. The stitches is also a place where we often hook in the custom data, maybe from proprietary databases with information such as contacts or location or other information that's useful to the operators, for instance. So once we've built all that, and the discovered topology model then pushes it out into the INSIM database, and that's where it's made use of by the rest of the product. So next slide, please. So when thinking about modeling your network, it pays to give some thought beforehand as to how you want to model it. And provision it with, as the network changes, of course, you're going to get new devices and devices getting made obsolete and so on. There's lots of options and different methods, so giving some thought to it ahead of time can make life easier over time. For instance, there are two specific modes I want to talk about here. The first is the fixed mode. Some customers find that all they want to do is to manage a definitive list of IP addresses. They're only paid to manage a fixed set of IP addresses, and they don't want to be concerned with miscellaneous devices. So they use seed files, and with the seed files, of course, if you split them, convenience for your administration, for instance, different regions or however else makes sense. You can also leverage multi-threading for the initial pings, side benefit. Now, if you're using this fixed method, you don't need to fill out the scope because the scope's implied. And so that saves a bit of work as you go forward. Also, in the discovery configuration in the advanced tab, you'd want to disable the feedback. That stops the discovery learning about new devices from other devices, from their network, from their routing tables and so on. Also, the file finder verification, you can uncheck that. Basically, if the what this does is that in your seed files, you've listed all the IP addresses you want to be discovered, and maybe one or two of them are not up on the network at the moment, and of course Discovery will ignore them in that case. So what this does is it tells Discovery not to ignore it, but to create it anyway. So that way, at least that you have a representation of it. You've got the IP address and so on. It's will be monitored so that when it comes up tomorrow, for instance, you'll get notification and you'll see it in the topology. On the other hand, most people use the scoped mode, which gives you a bit more flexibility in terms of finding devices. If you think of the scope as the fence or the boundary, then you can add the devices as seeds or subnets for ping sprays and so on as hints to find as many devices as you can. The big thing to watch out for here is that as you're adding new devices, sometimes you miss the scope. The scopes, of course, can be in subnets, so you can make large subnets that cover, make the fences broad, or as narrow as you like, down to individual devices. Another advantage of scopes is that if you have large edge routers, for instance, with large routing tables, then the discovery will use the scope to filter when it's doing the SNMP queries on these large tables, the routing tables and so on. So that's a side benefit of that. Of course, the feedback, you want to enable that this time because you do want to discover devices in the middle that have just popped onto the network, for instance. Same with ping spray. If you're using ping spray and you have large, sparse subnets like Class B, several Class B subnets which may be very sparse, then be aware that sometimes it might take more than 90 seconds to ping between two devices that are on the network, and therefore the discovery will complete as we saw before, and you will need to, it will automatically kick off the discovery again to pick up the remainder. But it's more efficient if you can make the ping spray subnets small enough so that for sparse subnets you don't have that problem. Seed lists themselves make the whole discovery a lot more efficient, and once you're getting to a mature state with your discoveries, you can use that script, the build seed list, to make it easy to build a seed list that you can use. The next slide, please. So when you're provisioning new devices, you obviously want to make sure those devices are ready to be discovered. And if the device is responding on the network, and whether the SNMP credentials are filled in within the network manager, so it can respond. So there's a handy script that is on the ISM library. The ISM library is where we put the prototypes and other interesting pieces that may be of interest to customers. And this is one such one. You can use this as a handy way of checking to see if the device is going to respond and whether the SNMP credentials within Network Manager are going to work for this device. It also does other things as well. For instance, after the discovery, you can use it to find which of the devices that did not respond to SNMP for some reason. And then after you fix those, you can run it again to verify that they have been fixed. And you can also use it to audit all the devices, for instance, audit in the sense of do they have, which ones did not have a sysname or an IP, access IP address, or any of these other attributes that you can put on here. So next slide, please. So now you've validated your devices. You can either wait for the next discovery and for it to be discovered, or typically you probably want to start monitoring these now before the discovery. So one way to do that is to use partial discovery to get them into the system. Now, depending on which mode you have, if you are in the scope mode, then obviously you've got to make sure that the scope has been adjusted. You've added the seed. and now for the partial discovery, you've got 3 ways that you can do this for your day-to-day work. One might be more convenient to you than another. So the add node script is one way of doing it. It automatically does the partial discovery for you. Just the partial discovery, you've still got to add it to the seed for the full discovery. You can also kick off a partial discovery within the GUI itself. This is sometimes handy if you happen to be there at the time. And the third way is to do it from a CLI perspective, so you could script something around this, and that insert command to the OQL is one way of doing that. One caution to have here for partial discoveries is that you don't want to do too many at a time unless it's in one block. Because each time you set one up, it'll start off a discovery, and if you set one off after another, it can make it very inefficient and maybe even conflict. So there's a few things to take note of with partial discovery that could cause you problems if you're not aware of them. When you first restart NCP Disco, for instance, partial discoveries are not going to work. They need a cache that is created during a full discovery in order to work. So when NCP Disco is restarted, make sure you run a full discovery before you attempt any partial discoveries later on. There's also a couple of factors that influence how long a partial discovery takes. Obviously, you want it to be as quick as possible. You're not looking necessarily for a full rebuild of the topology if you're just trying to monitor it. So if you disable the rediscovery rebuild layers on the Discovery Configuration Advanced tab, that will skip over the stitching, and the result of that, of course, is that you won't get the connections. But at least you'll know when it fails or responds. The other one is disable the rediscovery of related devices, and this tells the discovery not to worry about discovering new devices that it might find when it discovers the ones that you're asking it to. So, in other words, you're telling the partial discovery to only discover this device or these devices that I'm telling you to. The next slide, please. So at the end of the cycle, when do you actually remove devices? This is fairly straightforward, except there is some confusion in the sense that ITNM can automatically remove them for you. But the problem is only you know when a device needs to be removed. For instance, if it's not responding, is it just down for a little bit? Has it been removed from the network and never coming back? Only you know that. ITNM doesn't know that. So if you think about there are 3 possibilities here. The first possibility that a lot of customers use is that they don't want ITNM to delete anything automatically. They want to be in charge of when something gets deleted. And in that case, simply set the linger time to some large number. Or you can set it to -1, which would do the same thing. And then just use remove node to actually delete it manually or through some script. Of course, you also have to be aware of if the device is still on the network and responding on the network. Obviously, if it is and you've removed it, it'll just get rediscovered in the next discovery. So at that point, If it's still going to be on the network and you just don't want to manage it anymore, then you have to physically, you have to change the discovery configuration, adjust the scope and the seeds so it doesn't. And in which case, if you're in fixed mode, for instance, you can't just take it out of the seed file without also stopping NCP Disco. You have to take it out of the seed file, obviously, but NCP Cisco maintains that cache that I just mentioned before, so it'll still be in there and it'll reping it and rediscover it. But if you restart the NCP Disco, that'll take care of that. Remove node. If you're on 3.9, for instance, you're probably familiar with the fact that it does two things. It unmanages the device, and at the same time, it sets the linger time to 0. So the device will actually, first off, it will start getting polled, but it won't actually get removed until the next full discovery. In 4.1, it will simply remove the device immediately without a full discovery. The discovery, the next mode is that when the discovery automatically remove all non-responding devices. So if a device doesn't respond, you just want to get rid of it. And usually that's much too drastic, of course. But if you're undergoing significant re-IPing, then it can be a useful tool to try to keep the topology clean as you go from discovery to discovery. In which case, just set the default linger time to 0 for that period of time. And finally, the last one is what most people use, is some compromise between the two. You want ITNM to delete the devices, and the tool that we have is the number of discoveries. That gives you some sort of way of measuring the time frame, if you like. So after, by default, it's 3, as you know. So after 4 discoveries, I know you set it at 3, but it's actually after 3 it'll set it to 0, but it needs one more discovery to set it from 0 to -1, if you like, which will actually cause it to get removed. So it's after 4 discoveries it'll get removed. Now, if you do 4, maybe you're doing 4 discoveries, maybe in a weekend, for instance, you do a bunch of discoveries just for some other purpose. That, of course, is interfering with your policy of deleting devices. So be aware that you could be deleting devices without being aware, without knowing it. One way to avoid that is to run the report, which is called Devices Pending Delete on Next Discovery, and that will give you a list of all those that will get deleted if they don't respond. They're all the ones with linger time of 0. So next slide, please. So here's another prototype that can be useful for discovery. One of the things, and I'm sure Jenny helps you a lot with customizing the product to set up proprietary information and merge that in. And there's lots of different ways of doing that. One of the prototype here on ISM is called the Custom Attribute Manager, which we'd like to merge into the product at some point. Basically, this makes takes a lot of the custom work out of building this system. So it makes it a lot easier to not only customize and get that data into the system, but also manage it over time. And there's more information from the link at the bottom of the slide. So next slide, please. And the next section, we're going to cover the monitoring and some tips on monitoring the network. So next slide, please. First, when you're setting up policies, you're all aware that the topology includes who you're going to poll, that's the scope of it, the network views, and so on, what you're going to poll, and that's the poll definitions, and when you're going to poll, so on. Now, the poll definitions from 3.9 onwards, you can have multiple poll definitions in one policy, indicated in the box here. You see the poll policy with the scope, which is the network views and the device filter, and then the poll policy itself. It's the poll definition itself. What I want to show in this chart is how the filtering actually works. It goes to a lot of trouble to try to only poll and therefore throw events for devices or entities that you care about. So I want to show you how that filtering works so you can get some idea of how you can use it to advantage. First off, all the devices, of course, are in the NSIM database. That's how this graphic is working, that the devices first fall through the filter of network views. So if you might have set that to all devices, but if you set it to a view, for instance, then obviously it's going to be filtered only to the devices that are members of that view, and all those views are ANDed together. Then it falls through to the device filter. Now, the device filter further reduces those devices that have made it through the network views. So if you're only using the device filter, make sure that your network view is set to all devices. So those devices have fallen through the device filter now, and for each poll definition that it's going to go out and poll, there are two more filters it goes through. The device class is basically looking at the AOC class. And this is handy if you've got SNMP query to a proprietary event, a specific MIB, for instance, let's say a memory utilization or something. And the MIB variable is the MIB object ID is different for Cisco than it is for another vendor, for instance. So this way you can have separate poll definitions for each vendor, and with just a single scope that you've worked out above. So it'll go through and it'll look at the AOC class filter, just the devices that match that. And the last filter it goes through here is the interface filter. This doesn't change the devices. It still monitors all the devices regardless of the interface filter, but it gives you an opportunity to select which, if it's an interface poll, which interface you want it to poll. So, you know, various logical interfaces, for instance, you don't want it to poll, and maybe there are other, maybe you want to just focus on the gigabyte ones, for instance. And finally, when it's got through all of that, keep in mind also that it's only going to poll the managed entities. So the poller, after all that filtering, will only filter devices and interfaces that are managed. So next slide, please. So a little bit more on that poll definition filtering. This is more in the line of a gotcha. And one day soon, I hope we'll actually fix. So here we've got the poll definition class filter, and in the GUI on the right-hand side here, maybe you can see what I've done is I've unchecked one of the 3COM leaf nodes, if you like. That automatically unchecks the parent 3COM and unchecks the network device box as well. Now that's going to tell the poller not to poll anything that's in the network device class and not in any of the others, right? So if devices, for instance, that don't match any device class classes like Cisco, 3Com, Adtran, so on. By default, they'll get dumped into the network device class. You're probably familiar with that. They will suddenly stop getting polled. Same with the 3Com parent. That's unchecked there. So the thing to watch here is don't ignore that AOC or the device class filter. When you're setting up your poll definitions, always check and make sure that all the classes are checked that you're wanting to poll. That can be a surprise if you don't. The interface filter, this can be very handy when you have large numbers of interfaces and you don't want to poll all of them. So it can save polling time and resources. One thing to note here, there is an overhead for using the filter because we're now doing SNMP gets individually instead of a more efficient SNMP get next. So if you're only filtering out a few interfaces, it may be more efficient just to not use it at all and just do the SNMP get default SNMP get next. Another consequence of using the SNMP gets is that it has to build the SNMP get packages, which can sometimes result in too big error messages coming back from the device. And we handle that by, okay, it's too big, so we divide it up and send it out again. And this makes polling very inefficient as it's doing multiple polls to try to get a package that is within size, if you like, of the device. One way to avoid that is to set the aggregation limit in the NC poller schema configuration file. Set that to a lower number like 10. Okay, the next slide, please. So back to the unmanaged status. I don't know how much you know of the unmanaged status individually, but there are several levels. 0 is obviously the managed, and so it will get polled. And maintenance mode, what we call maintenance mode, is when you set it or unset it from the GUI. You can also set it and unset it from those scripts, the managed node and the unmanaged node, Perl scripts. Now there's two other levels. Basically, these are set within the tag managed entity stitcher during discovery. So that during discovery, you can say, you know, all these logical interfaces, for instance, I'm not interested in polling. So there are a bunch of filters in there, rules in there, if you like, that you can add to or take away in order to control the automatic unmanaged status on the interfaces. And the last one I want to talk about here, because it can catch you unawares, it also, if the IP address itself is not in scope, then it's not going to get polled. Now, if it's not in scope, how do we discover it? Well, these are the interfaces at the edge, the other side, if you like, of edge routers. So we're not discovering the subnets on the other side of those devices. That means we're not managing. We'll discover the interfaces, but we won't poll them. And this sometimes is not what you had in mind, so you need to be aware of that so that you know they're not going to get polled and make adjustments if you did want to poll them. So we go to the next slide, please. So that tag manager entity stitcher that I mentioned, there's one entry here that frequently causes problems, and I want to point it out so that you're aware of it and can fix it. Often we're using a rule here based on the if descriptor, and the VLANs are often logical interfaces that you don't want to poll, but the lowercase one, the capital V lowercase LAN, often is active on IP interfaces that you do want to poll. So if you add to that rule another check for the is active attribute not equal to 1, then it'll make sure that active IP addressed VLAN interfaces do actually get polled. So next slide, please. So there's a lot of checking we've just been through. However, there is a very handy tool that you can use to take care of all that for you. Basically, the tool consists of 3 Perl scripts. And what it does is that you give it a set of IP addresses. They can be all the addresses, for instance, that you are responsible for managing. And then it will go through, and for each one of those IP addresses, it will tell you which ones are not being polled and why they're not being polled. So it will do all those checks that we were talking about before and let you know. Basically, it runs the first script is where you upload your IP addresses. You can do that for a single IP address, or you can do it for hundreds, tens of thousands. And every time you upload them, it'll just overwrite the previous set, so reset it. And then you run the second one to take a snapshot at that moment, and then finally you run the report. That will, and on the next slide, please. It will report one of these categories. So undiscovered indicates that the scope, the discovery itself hadn't discovered it. Out of scope means that we've got it, it's discovered, but it's not in any of your policy scopes. So for some reason it was missed out there. Unmanaged gives you an idea of what type of unmanaged, whether it's in maintenance mode or whether it was from the tag managed entities. And running this script is often the first inkling you have that the tag managed entities is either being too aggressive or not aggressive enough. Or it can be your IP address, for instance, might be a secondary or an unpingable interface. So it'll give you one of those categories. So next slide, please. So that was the ping polling that we went through in terms of the checking. What about SNMP polls? We don't have a set of, or that previous set doesn't handle the SNMP poll policies that you set up. Although it's handy in general because it will answer a lot of the same questions. Typically people use OQL to check the tables. It's like getting your fingers dirty. There's a new capability here with the ITNM poller script, which can now display the status of all the polls, including the interface polls, which it didn't used to be able to do. And that is available from 3.9 Fixpack 4, interim fix 1, and also from 4.1.1 Fixpack 1, basically the latest versions. However, it does need an additional APAR, and the tech note below, the link in the tech note below will tell you how to get that APAR. A couple of useful SNMP queries. For instance, you might, that check we were just talking about with the ping, maybe you don't have a handy IP address list of all the devices that you're responsible for. I want to just use, well, I'm good with all the IP addresses that are in the database at the moment. Give me a list from there. So that's what this will do. So we go to the next slide, please. So for 3.9, we've had the capability of having multiple polars, and this helps as you are polling at the higher scales. We find that it's more efficient if you can have multiple polars. In particular, we isolated one polar to do all the admin work, which also means that the polar is now the other polars are now free to concentrate on polling, and can handle a higher load as a result. So by default, kind of like a best practice, you can configure these polars. One of them, set it as the admin polar. Now, if you don't set it, it'll the default the polars will automatically be admin. They'll do the admin work as well. So that's fine. But I would set it to admin just to make it explicit. I'd also use the admin polar to do any real-time polling for the MIBgrapher, so that way your users, when they use the MIBgrapher real-time polling, you don't have to worry about them overloading the polar, peak times, for instance. Normally that doesn't happen, but if you're at high levels of scale, those sort of things are also important. Now, depending on your network, you may want one or two or even more polars. Typically, one polar that's dedicated to ICMP polls is usually big enough for even the biggest networks with a 5-minute frequency, because they're pretty lightweight in general. With SNMP, it depends how many interfaces. Obviously it depends what you're polling. If you're polling interface variables and you have lots of large interface tables, and particularly if you're storing the data as well, then you might get to the point where you want more than one polar dedicated to SNMP. So if we go to the next slide, please. So when you're setting up these polar instances, basically you just got to register it and set it up to run in the control services. But to make it, again, a kind of a best practice convention, if you like, there are two names associated with each polar. One is the service name, which is actually used, by the operating system to keep track of that process. And you might want to label that service name or prefix it with NCP. That way, when you do greps, PS greps, for instance, they'll appear just like all the other NCP processes. Within the polar itself, you can give it a name which will appear on the GUI for when you're setting up the network policies. That'll appear there. There's the admin switch. Again, you don't have to set this because it's default. It is the default, but I would recommend setting it as explicitly as admin, so you know it's been set. The no admin is the one that you want to set on all the others, so it will not do any of the additional heavy lifting for that the polar does in its housekeeping. And number two is the register. You have to register the polar in the database. Note that the default polar out of the box doesn't have a name, so it will appear on the GUI as default polar, and that's just fine. But if you're wanting to rename it, for instance, to be more explicit with your with what it is or so on, you can rename that. Now, to query the OQL tables, if you're used to querying the SNMP polar OQL table, for instance, then you need to tell it which instance, polar instance, your query, and there's an additional argument, the dash polar, with the name, again, that GUI name for the polar. Okay, next slide, please. And the next section is going to be on the events. In particular, when you're integrating events from third-party tools with topology and wanting to integrate them with the ITNM's topology for additional information on the events, RCA, and so on. There's a few columns that you have to pay attention to so that it will work off those columns. The best practice, so what this slide is really doing is pointing you to a best practice guide for these, that describes these fields enrichment. It has on the right-hand side, I've just taken the diagram that it goes through of the different processes and where the fields typically get filled in as the event travels around the system. From coming into the system through the probes, you want to make sure that you have the local node alias set for a IP address or a host name that it will use to try to match a device. And also in 3.9, you also want to set an event map, and that tells it how it's going to process it later on. After it gets into Omnibus, the event gateway immediately extracts all the events. It's doing this all the time that have local node alias assigned. So if you didn't assign it with a local node alias, then it won't get the opportunity to be enriched here. So the event gateway now takes it and it does a number of different things. It calculates it matches it first, and then enriches it with all the topology data, the other NMOS fields, columns in the event, and sends it off to the various plugins, which includes the enrichment, includes the RCA, and there's a few others it might. And they also go through the event map. The NMOS event map will guide it in how to enrich it and whether it goes through RCA or not. Anyway, more information there in the best practice guide. It also, that document explains the RCA, all the different rules that make up the RCA, the categories. It shows from an event perspective what the events look like before RCA kicks in, so all the events that you might expect to come in, and then after RCA, what it's done to those events. Typically, it will have made one of them the root cause, so it'll appear red here, and it'll make all the others symptoms, so the purple color, as you're familiar with. And then it'll also give you a visualization for it. So the RCA rule that we're all familiar with and think about all the time is the downstream suppression, but there are actually quite a few other rules relating to neighbors, containment, and so on, in order to do its job of filtering events so that you only have one event to take care of. So next slide, please. So this section, if you go to the next slide, is on the administration tasks that can help. One of all the processes, or some of the significant processes like Disco and the Polar, issue events when things go wrong, or just issuing events illustrating the stages that it's going through. So it gives you information about how things are working, sort of like a health alert. So if you haven't already, it's useful to get an event list filtered just to the ITNM status, or the ITNM Disco and the Web GUI status. So those alert groups will cover the process events for monitoring here. When you set up the AEL, for instance, you might want to also add two other columns here, the local pre-obj and the local sec-obj. They, for a number of these events, will have additional information that you might find useful here. Also a way of indicating what failover state, for instance, the system might be in when you come in the morning. Okay, next slide, please. So you've come in the morning, discovery's run overnight. How do you determine whether that discovery or how it's gone? Assuming it's run successfully, you still have to check to see, well, did it discover the things I was expecting, or were there network problems, or were there SNMP problems, and so on. So you want some way of quickly checking that discovery, and the handy way of doing that is looking at the profiling data that we generate for each discovery. So if you run that script at the top there, that will output that profiling data in a handy table. And quickly eyeballing this table will give you an idea of how the latest discovery, which is at the bottom, compares with previous ones. And that will alert you straight away whether, for instance, a model has suddenly consumed more memory for some reason or less. Same with the discovery memory. And those two memory things are handy if you're continually adding more and more of your network to the discovery. And you're wondering, when do I have to set up a new domain, for instance? So this is one indicator that can be of use. The counts of the number of interfaces, number of devices that have SNMP access, number of devices that were discovered, number of entities, all that can be useful to say, well, yep, discovery is in the ballpark of what I imagined, or whether it's way off. Also gives the timing for the various sections from the initial data collection to the processing and finally the transfer into the topology. They can vary for a number of reasons, of course. How busy the system is at the moment, how the network is doing. This has also been an indicator we found in some customers where, like in this case here, for instance, you can see the transfer time and the total time is increased significantly from the previous time. And in this particular case, it was because the network was having problems and it was just slower. So it was an indication of that as well. If you want to run this and the discovery is not running, you can also run it from the caches. So it's flexible from that point of view as well. Okay, so next slide, please. So okay, that's fine. Discovery's run, and you've checked out the major profiling numbers. But I still want to know what new devices I've discovered in this run. So here's a handy SQL query that will list all the devices that have been discovered in the last 24 hours. I mentioned before about the report, if you want to test to see which devices are going to get removed in the next discovery. In other words, linger time is 0. There's a query for that. And also, if for instance, you want an actual event when a new chassis is added or an interface is added or deleted for that matter. Normally, you wouldn't do this because it'd be a lot of events unless your network is fairly stable, in which case this might be useful to you. So there's a configuration setting here that you can set so that it will generate those events for you. Okay, next slide, please. We talked about the discovery profiling to look at the health of the discovery run. The poller, especially as you're adding more and more polling to it, we want to know how the poller is handling it. If a poller starts to slow down, for instance, then it's not going to be polling everything. If you've got it set up for polling every 5 minutes, for instance, it will poll everything in that that it's scheduled to in that 5 minutes. But if it took longer than 5 minutes to actually poll, it'll give up then and restart. So there'll be a number of devices that didn't get polled. So that's important to understand, so that as the poller is getting overloaded, you're actually, it isn't just a case of the polar slowing down, but it's actually dropping poles in order to keep up. So how do you know? Well, we've done a lot of work over the last couple of years to increase the scalability of the polar, so it can now handle a lot more polling than it used to. And in the process of doing all that, we've built in some instrumentation that we can use here to see how what its health is. And basically, it can answer these questions, or it's designed around these questions. If you're storing data, for instance, then is that storage of data working fine? Is it getting maintained, getting pruned, and so on? Is the polling load at the scheduled frequencies working out for you, or is it dropping devices? Is the poller's memory stable? Is it the more devices you poll, the more polar memory you need or it consumes? In which case, you probably want to add a new poller. So it's going to answer those questions. And when you run the script that does this, it outputs a set of retro-styled graphics, basically ASCII graphics of the statistics over time. So you can see not only where it is right now, but you can see how it's trending, whether how memory's been trending upwards or whether it's on a stable plane, that type of thing. And hopefully the future will have this on the GUI, so it'll look a little bit more sexy and easier to use. But anyway, that gives you good information on the visibility into the polar at the moment. And all that's available in the latest fix packs, 3.9 and 4.11. Okay, next slide, please. So this slide is basically a plug for the best practice guide for Network Manager relating to the database, DB2 in particular. It covers settings for the configuration settings, tuning suggestions, and also maintenance. Most of the configuration settings, the default configuration settings for DB2 are usually okay, but as you're making more and more use of it, of course, you might want to change those. But it gives you an idea of some best practice settings there and tuning suggestions. If you're storing data, that's where you're starting to use the database more heavily. And we found that increasing the buffer pool will allow you to store a much higher rate of inputting data to the database. I think the default is something like 8,000, and we're suggesting here, or we've tested here up to 500,000 bytes for the buffer pool, which uses up to 16 gigs. So you're trading memory basically for the insert rates. Along with the buffer pool, the other thing to keep in mind is the transaction log maintenance and making sure that the transaction log settings are adequate for the task. As a result of that, the rate that we can support is increased dramatically from something like 7 million rows a day to 5 million rows an hour. So increase that significantly. Okay, if we can go to the last slide, please. In that same best practice guide, there's also a handy reference for changing the database password. Most of the DB2 operating system-based accounts are often subject to security regulations requiring them to be changed. And if they have to be changed, then that means that any products using them are going to have to be updated. And so this will show the 4 places where you have to actually change them. The read-write database account name that is being used by ITNM is configured at install time in the DB logins file. So if you're not sure what the account name is, you can always find it there in the system. So there are 4 places: the ITNM backend, that's in the DB logins, as well as the MIB logins, 2 files there. In the GUI, there's a GUI that will actually allow you to change it, and that will work for the GUI itself. And then the BERT and Cognos reports, they need adjusting as well, and the commands there to do that. And if you're using NCM, the NCM uses a topology API there, and so there's a script there that will change the password for you. So that brings us to the end of the best practices that I wanted to cover today. So back to you, Kate.
All right, thank you so much, Rob. And I do have a few questions for you. One question is, where are the metrics for that ASCII graph stored?
Where are the metrics for the what? Sorry, hang on, let me see if I can find it.
Like ASC 11 or II? We can answer that one offline if necessary.
I'm sorry, I'm just drawing a blank. ASP?
It could be. Let me. No, I don't. We'll circle back to that one offline.
Okay.
And the next question is, what does the query look like to generate the polar performance graph?
Good question. The link at the bottom of that will take you straight to the Knowledge Center, which will show you it's the ITNM polar Perl script, and it has all the arguments that you need.
Okay, perfect. Thank you so much. Okay, thanks, Rob. And we're going to hand it over to Sean now to quickly go over how you can leverage Jenny to do some of the heavy lifting around these best practices for you.
Thank you, Kate, and thank you, Rob, for that very informative review of Network Manager best practices. As Rob had stated at the beginning of his presentation, there's really 2 major categories of ways that you can approach your discovery, whether that's the seeded list of IPs or a scope discovery. And really, it's in the planning phase that really you need to go through that activity and understand what the implications are of the various approaches. And so part of what we can assist with, whether it's a new rollout or whether it's optimizing an existing rollout, is analyzing your discovery scopes, help you understand what advanced discovery capabilities exist, review the various agents that can be enabled or disabled as part of your discovery, and then which devices really, how much information we can really get on those devices. As far as the network monitoring, understanding the current monitoring state, understanding future goals within your organization, whether that's for polling, the definitions of how the pollers are set up, SNMP, ping polls, and the filtering. If a lot of time there's additional devices that are discovered that are difficult to get out, so we can assist with that filtering effort as well. From a network management perspective, again, it's doing the validation of the discovery, the network devices, the interfaces, and making sure that what's in your topology represents what's on your network. From an event management perspective, reviewing the configurations and process and ensuring that all of these configurations within Network Manager align with the best practices that Rob has reviewed with us today. That's really where we spend the majority of our time within deployments, is ensuring that whether it's a greenfield deployment and we're setting it up from the ground up, or taking an existing deployment and through the upgrade process enhancing and migrating your settings in a way that optimizes the functions within Network Manager. And it really comes down to leveraging the vast suite of capabilities that Network Manager offers. And it takes some time to go through that analysis, but on the end of that, what you're left with is an optimized efficiently running network manager that really leverages your investment in this product. Some of the other things we offer on top of the IBM products itself is Jenny Ops Center. We provide a Netcool knowledge library that includes MIB support beyond the standard Nickel libraries. It also enhances the existing MIB support within the stock IBM Nickel libraries, and that allows you to do that event ID tagging in a meaningful way that allows you to truly leverage the RCA capabilities within Network Manager. And then from an administration standpoint, we offer a Netcool dashboard that really shows you not only up-down state, but also performance metrics associated with each of the components within your Netcool infrastructure. And so if you have any questions about how Jenny can help optimize and improve your monitoring infrastructure and help you better leverage your investment in these products, please send us an email and we'd love to talk to you. Back to you, Kate.
All right. Thanks so much, Sean. If you have any questions about anything that you've heard today, please feel free to email me at kate@gen-e.com or contact your account executive. And this concludes today's webcast. Thank you so much for joining us, and have a wonderful day.